Now, we have already seen in the CBT Nugget series on the CCDA just how network management protocols can help us not only manage an existing network, but help characterize an existing network when we are thinking about design issues for that particular infrastructure. Well, in this CBT nugget, let's really focus on some network management protocols. This is by no means meant to be comprehensive, but we will focus on some of the most popular and some of the most important network management protocols today. So we know in this nugget that we are going to take a look at some important network management protocols, but which exactly are they? Well, the first that we'll look at is the star of the show, really. It's Simple Network Management Protocol. This will be our lengthiest discussion, and this is a very sophisticated suite of protocols that we are going to utilize in order to do some pretty profound network management stuff. By the way, don't confuse this with simple mail transfer protocol. Maybe you don't do that, but I always had this trouble and I always confuse these two. This, of course, is the acronym for the protocol that handles mail, email traffic, and this is network management. Simple Network Management Protocol calls upon a protocol oftentimes to assist it, and that is the Remote Monitoring Protocol. We'll see how it can be used by Simple Network Management Protocol to do really more of an accounting function when it comes to certain network characteristics. Speaking of accounting, if you're really interested in accounting for how your links are utilized by the IP protocol, then NetFlow is something that you want to consider, and we'll take a look at it. NetFlow can produce the equivalent of like a phone bill regarding how your network is utilized. Cisco invented the Cisco Discovery Protocol so that you could take one of your devices and automatically discover all of the devices that it is connected to. We'll explore the Cisco Discovery Protocol. We'll see how to get the most out of that protocol, and we'll even see how to turn that protocol off if we are concerned about security issues with CDP. Finally, we'll wrap up this nugget by taking a look at syslog accounting. We know that devices from Cisco are going to be very chatty with what are called system messages. Yeah, the devices are constantly saying what's going on with them. They're constantly reporting on their health. They're reporting on particular events that are occurring to them. And we'll see how to leverage this information for various accounting features. Simple Network Management Protocol was derived as a standards-based way in which to manage equipment. Let's say we have a Cisco router, the R1 router. This is what we call a managed device in Simple Network Management Protocol terminology. This is managed from a PC running typically graphical user interface management software, and our desire is to manage this device, and this is called our Network Management Station, or NMS. Now, this managed device is running specialized software, which we call the Simple Network Management Protocol Agent. So there is software called the agent software running on this managed device. The network management station sends GET requests to obtain information from the managed device. And if it wants to set certain behaviors or parameters on the device, it can send SET commands to the managed device. Now, another important piece of terminology we need to understand with Simple Network Management Protocol is the Management Information Base, not to be confused with Universal's Pictures Men in Black. No, no, no. No, this is the Management Information Base. And what this is it's just a standardized database of all of the different variables that make up the network device. For instance, there will be a variable defining the interface output count, right? How many packets have gone outside of the interface over a certain time period. So there are these standardized variables that are put together in a management information base. And when we set those set commands and get commands, we are reading from these variables or writing to these variables. So this is how Simple Network Management Protocol works. It reminds me of the OnStar service that you can get for modern vehicles now. There is a database of parameters that define my vehicle. One of those parameters might be left front tire pressure. That's right. And the network management or the OnStar system will go in and monitor my left front tire pressure, and they will send me an alert if this left front tire pressure goes outside of a certain range. This is a lot like the functioning of our simple network management protocol. Now, you're probably not surprised to know that SNMP began with version 1. And version 1 was very basic. It defined a get message. And as we indicated, the get message was to retrieve information from a managed device like our router. The agent would go ahead and handle this get request. And as you know, it would get information out of a particular MIB variable. They also defined the get next message type, and this was obviously to obtain additional information from the variables. And they developed the set command, which could be used to actually configure the device. Let's say there's a MIB variable for the host name of the device, which there certainly is, and we could use a set command to change that host name using Simple Network Management Protocol. They obviously needed to define a get response type message, and they did. And they also invented with version 1 the concept of a trap. What is a trap? Well, let's say we're monitoring switch 2, and we decide to define a threshold of the internal temperature on switch 2. Yeah, we say, look, if you get above 80 degrees, then that's a problem. So what we want you to do is send a trap to the network management station that says, alert. Yeah, danger, Will Robinson, danger. The temperature of this chassis has gone above a particular threshold. You see, this is a nice complement to the get feature. If we want to check the chassis temperature using gets, we're going to have to do that every what? Every minute? Yeah, this is called the polling approach of Simple Network Management Protocol. Every minute you say to switch 2, what's your temperature? What's your temperature? What's your temperature? You do this minute after minute after minute. Well, wouldn't it be more efficient to just tell switch 2, hey, please alert with a trap operation when your temperature goes above a particular threshold? So traps were invented in SNMP version 1 to complement the approach of constantly polling. Now, the next major version of Simple Network Management Protocol that came along was version 2C. And version 2C tried to introduce some security. They came up with the idea of a community string in order to protect the SNMP protocol. But this was a failure from a security perspective. Why? Because the community string is nothing more than a clear text password. Yes, this is so pathetic from a security perspective that people joke, or at least joked, that Simple Network Management Protocol stood for security, not my problem. I mean, if we're going to send a clear text password as the security mechanism, someone can easily intercept this communication, see the password in clear text, and then impersonate an approved network management station. SNMP version 2C not only introduced this community string behavior, but they also introduced a get bulk type messaging procedure. This would prove more efficient than the get and get next approach when we're wanting to receive lots of different MIB variable information. And finally, SNMP version 2C introduced a new concept called an inform. Do you remember the traps that we spoke of? Well, informs are just like traps. They will have a device proactively send a message to the network management station based on some threshold value. But the difference between a trap and an inform must be acknowledged by the network management station. So a lot of people say informs are reliable traps. When we want reliability inserted into the trap type behavior, we go ahead and we use an inform message that was defined in SNMP version 2C. Now, it probably doesn't strike you as a big surprise that the third version of Simple Network Management Protocol finally addressed security head on. With SNMP version 3, we can do authentication. So we can really determine if a network management station is who they claim to be. We can do integrity, meaning when we're sending those gets, or we're getting the responses, or we're sending those sets, we can ensure that this information has not been changed in transmission. And then finally, we can do encryption. We can take all of this network management traffic messaging and we can encrypt it so that if it is obtained over the network wire, it cannot easily be decrypted. So it can't easily be read like we had with clear text communications in previous editions of the protocol. What's nice about Simple Network Management version 3, Simple Network Management Protocol version 3, is that we can determine exactly what level of all of these security mechanisms we want or we need. So we don't have to run version 3 with all of these security mechanisms if we don't require them all. So it turns out that we can operate SNMP v3 in 3 different manners, depending on the level of security that we want. We have no, auth, no, privacy. And that is literally how we see it when it's configured this way at the command line. No authentication, no privacy. This means we're not doing any fancy authentication. We're not doing any fancy encryption. Is this stronger than SNMP version 2C that we had before? The answer is a resounding yes, and that's because at least we'll use a username and password combination. So instead of using a simple clear text password, at least we'll be relying on a username and a password in order to gain access to the information. Now, we could operate in auth, no privacy mode. And obviously, with this method, we're going to do nice, strong authentication and integrity protection, but we won't do encryption. And then if we are interested in the strongest security, we'll do auth privacy. We'll do the strongest authentication, the strongest integrity we can do in the protocol, and we'll also do the strongest encryption that the protocol offers. So if we are in low security environments, they give us an option for that. If we're in high security environments, they give us an option for that as well. Now, before we leave our discussion of Simple Network Management Protocol, let's elaborate on that standards-based database of variables for network management called the MIB, the Management Information Base. It's a tree-like standardized database structure. So What happens is you start at like the ISO level, which is identified numerically as 1, then the org level 3, Department of Defense 6, Internet 1, Management 2, MIB 1, System 1, Interfaces 2. And what happens is you have a numerical way that you can describe a particular MIB variable. So we know the interfaces are in 1.3.6.1.2.1.1.2, and you can describe things based on a numeric identifier of where that particular variable lives within the tree structure of variables. Pretty cool. Now you might say, well, wait a minute. Cisco obviously has some proprietary inventions for equipment, and those are going to have proprietary MIB variables to manage them. And this is where the tree branches off into what are called the private management information bases. So we have public management information base variables, and then for specific vendors that want to create their own unique devices that will have their own unique management variables, we have the private MIB structure as well. Now, guess what one of those management information base tree branches is? Yep, it's remote monitoring. This is kind of like a sister protocol to Simple Network Management Protocol. The idea is, let's say a router will store all of this RMON information itself. Yeah, the router will go ahead and collect and store all this information. It kind of works in conjunction with the Simple Network Management Protocol agent. If this remote monitoring information needs to be forwarded to a network management station, using, of course, Simple Network Management Protocol, it can be. But if we as a network administrator just want to go right into the router and check out the RMON data, we can. RMON 1, okay, RMON version 1, if you will, identified some groups of information that it could maintain. One of these groups is called statistics, and this is information like packets sent, bytes sent, broadcast packets, multicast packets, errors. There was a history piece of information stored, and this is for statistical samples of periodic information. There was an alarm that was defined in the RMON group, RMON 1 group, and this alarm would be for setting particular thresholds. There was a host category that was defined for containing statistical information associated with each host that's discovered on the network. There was the host top N category, and this contains statistics for hosts that top a list for specific observed variables. There was a matrix category defined for conversions between sets of two different addresses. There was a filter category defined for rules for certain types of data packet filters, and then a packet capture category. And the packet capture category was literally for capturing data packets that match a specific set of rules that we have in a filter. And then finally, events. The events category was to control the generation and notification of events that this particular device would do for remote monitoring. RMON 1 was a big hit as a way in which to enhance what we could do with Simple Network Management Protocol, and that's why it's no surprise that this ended up leading to RMON 2. Now, RMON 1 was great, but RMON 1 was really limited to the physical and the data link layers of the OSI model. So RMON 2 sought to go ahead and add groups that could give visibility higher up in the OSI model, right? So we had visibility into the network layer, into the transport layer, even visibility all the way up to the application layer. An example of one of the ARMON2 new groups would be the application layer host. The application layer host would contain statistics for particular application layer traffic. So Armon 1 was built upon by Armon 2, which would enable us to get visibility into statistics beyond the data link layer. But wait a minute. We have simple network management protocol for taking the temperature in certain variables, right? For checking in on certain variables from network management perspective, and maybe even configuring the device from a network management perspective. And then we have remote monitoring, which works in conjunction with simple network management protocol, but it's for specific MIB variables once again. What was needed was a protocol that would go ahead and just really focus in on IP usage within the organization. What links are busy? What links aren't busy? What devices are sending or receiving a lot of IP traffic, which aren't? And that's what NetFlow was invented for. It can do accounting/billing for IP usage. Obviously, it can help us plan and design networks and new network infrastructures. It can help us with a security planning for the organization because now we know exactly where IP traffic flows are happening and in what kind of capacity, and obviously it would be very valuable for monitoring the network and guarding against choke points in the network infrastructure. There have been many versions of NetFlow, many versions. Like version 1, version 2, version 4, version 8. There's even the latest NetFlow, which is called flexible NetFlow, because it will allow us to define exactly what parameters of the IP traffic that we want to monitor. But regardless of the versions of NetFlow, just understand that it is a way in which to gauge the overall IP data usage throughout the network infrastructure. Now, Cisco was very interested in helping you with network management by inventing the Cisco Discovery Protocol, a layer 2 protocol that you can enable for the entire device, and then you can enable or disable on an interface by interface basis if you want to. Now, Cisco devices default to this feature turned on and pretty much enabled on every single interface. But let me show you how to control that. While this is not a particular course in implementation, as you know, this one I'm compelled to show you or remind you how to control. Because think about it. If you have a router that connects out to the scary internet, you don't necessarily want that router announcing its IP address, its capabilities, its type out to the internet, because this could be a real issue from a security perspective. First, how would you use CDP? Well, on R1, I would say show CDP neighbors in order to determine if I am connected to any devices. And sure enough, I am. I am connected to a device named R5. It is out my fast Ethernet 0/0 interface. That device out there is capable of routing, switching, and doing multicast. It is a 3725 device, and I'm connected to its fast Ethernet 0/0 port. If I want more information, I can say show CDP neighbors, and we can use the detail keyword. So I can say, all right, give me even more details about that particular device that I am neighboring with. By the way, we can even see the IP address of that device that we are neighboring with. But as I said, CDP might be problematic from a security standpoint. So we can go in global configuration mode and we can say no CDP run. and that would turn CDP off on the device in its entirety. If we just wanted to trim the feature off on an interface, we would say no CDP enable. So there I've turned off Cisco Discovery Protocol under the interface. Now don't be surprised when you do your show CDP neighbors and the device is still there, because there is a hold time associated with this information. So even though I've turned it off my Fast Ethernet 0/0 interface, I'm going to need to wait for the expiration of the hold time before this R5 entry ages out of the CDP table. Now we recall that Cisco devices are going to generate these system messages. IP might generate them. OSPF might generate them. How about IP security? How about, let's see, the route switch processor? All of these are examples of facilities that exist on the router that might generate system messages. System messages have a severity level. If it's a 0 system message, this means it's an emergency. If it's a level 1 message, it means that it's an alert. A level 2 message is for critical events. A level 3 message is for errors. A level 4 message is for warnings. A level 5 message is for a notice. A level 6 message is for informational. And then a level 7 message is for those debugging messages that we can run at the command line. Wouldn't it be valuable to configure your Cisco device, let's say R1, to send these system messages to a server running syslog software that could literally do accounting on all of these various messages you receive? Wouldn't it also be nice that if your device throws one of, let's say, the top 4 most critical system messages, that you get a page or an email to alert you that that has occurred? So, devise and design for the networks that you are going to be responsible for. Design a system messaging process. Consider the use of an external syslog server in order to account for and potentially alert based on these system messages. Think of how powerful this will be when used in conjunction with Simple Network Management Protocol. Yeah, now you have those traps and informs set up in SNMP, and they're working in conjunction with these system messages. Think about it. Aren't these system messages a lot like Simple Network Management Protocol traps? We don't initiate them. They're initiated by the device themselves, and they are intended to give key information about what is transpiring for the device from a network management perspective. So in this nugget, we took a look at some of the most important, some of the most popular network management protocols. We took a look at Simple Network Management Protocol with its managed devices thanks to an SNMP agent and of course that database of variables called the MIB. We took a look at remote monitoring, which snaps right into the Simple Network Management Protocol architecture. We talked about NetFlow, which creates basically like a phone bill type report for us regarding IP usage. We saw Cisco's own invention, the Cisco Discovery Protocol, and we saw how to turn it off for the entire device or trim it off an interface. And we wrapped up by discussing syslog accounting, how important it is for us to get our hands around the intense number of system messages that our device might generate, and how we can send those messages to a syslog server so we can try and make some sense of them. Again, these are just some of the network management protocols that we can take advantage of today. I hope this has been informative for you, and I'd like to thank you for viewing.